Well, hello. Welcome to Solar Alberta's 2021 seminar series. Today, we're going to be learning about Fort Chipewyan's road to a lower carbon energy mix. We'll be hearing about Canada's largest off-grid solar project, which is the result of a partnership between 3 Alberta First Nations. We are delighted to have so many people register for this event. Please note that we'll be recording this webinar for future distribution so that those who missed out on registering through Zoom can still participate. My name is Heather McKenzie, and I am the Executive Director of Solar Alberta. I'd like to take a minute to acknowledge that I'm hosting you today from Treaty 6 territory in Edmonton, Alberta, Canada. Treaty 6 territory is the traditional gathering place and home of many Indigenous peoples, including Nehiyawak or Cree, Saulteaux, Dene, Papaschase, Blackfoot, Nakota Sioux, and Métis, nations whose ancestors' footsteps have marked this territory for centuries. Today, we will hear from 5 speakers, and then following their presentation, we will be taking some time for a question and answer period in which you can all participate. Throughout the event and after, you are encouraged to give us a shout out on social media using hashtag SolarAlberta. We're going to be using Zoom Q&A for questions rather than the chat box, so please enter your questions in the Q&A section. You should be able to click on that section in your Zoom toolbar. You can upvote good questions that others have asked or post some of your own. The questions that are voted up will show up at the top of the list, and we're going to pull primarily from those for the moderated Q&A, as we likely won't have time for all questions. And now just a little bit about Solar Alberta to kick things off. Did you know that this is Solar Alberta's 30th year of operation? That's right. Solar Alberta is a not-for-profit society that is dedicated to public education about renewable energy and energy efficiency. We also serve as a hub for the solar industry here in Alberta, and we connect the general public to industry providers through our solar industry directory, our Alberta solar map, our regular events, and much more. We are offering a number of webinars on Thursdays over the lunch hour between now and October. You can also find archived videos of our previous webinars on our website. We're currently accepting registrations for our June 3rd event, at which we will learn about utility scale solar and about Alberta as the solar powerhouse of Canada. So please see the registration link that we're going to post in the chat box for that upcoming event. We're always interested in developing more partnerships for our events. If you or your company want to work with us to educate the public about the benefits of renewable energy, energy efficiency, and climate change, please don't hesitate to reach out. Also, if you'd like to support the work of Solar Alberta in general, please consider participating in our latest 50-50 fundraiser. And we're going to post the link for that in the chat box as well, so you can get a ticket today. This entire series is free and open to the public thanks to the generous support of our members, volunteers, and financial supporters. We are pleased and grateful to have ATCO as the premium sponsor for this Lunch and Learn event. And now I'd like to make some introductions. So we're pleased to have with us today 5 engaging presenters. Brian Harris is a sales manager with ATCO Infrastructure Services, and he has been with ATCO for over 8 years. He's worked with a variety of divisions within the company. Brian's key focus is currently on community and utility scale renewable energy projects in Western Canada, and with a specific focus on Indigenous communities in Alberta. Welcome, Brian. We also have with us Matt Wright. Matt is a supervising engineer with ATCO, leading a team of engineers responsible for developing, executing, and commissioning renewable and energy storage projects for utility, commercial, and industrial systems. He's also responsible for supporting critical operating functions within the electrical network and within the transmission and distribution departments as it pertains to distributed energy resource systems and isolated operations. Welcome, Matt. Thanks for joining us. Next up, I'd like to introduce Hassam Yazdempanahi. He joined ATCO in 2013, and he is currently a senior electrical design engineer with the strategic projects team. In his current role, Hassam has been involved in several solar PV, battery energy storage system, and combined heat and power projects. Hassam received his PhD in energy systems from the University of Alberta in 2014. His PhD research focused on distributed energy resources and their impacts on utilities. I should have called you doctor. I apologize. Welcome, Hassam. Thank you for joining us. And also with us today is Clayton Stafford. Clayton is a senior partner at Green Planet Energy Analytics and project manager for Three Nations Energy, which you may also hear referred to as 3NE. He brings over 30 years of experience leading business-changing projects in small businesses, large businesses, and public sector organizations. Welcome, Clayton. Thanks for joining us today. Next up, and the last of our 5 presenters, last but not least, is Jason Schultz. Jason currently serves as the Director of Strategic Advisory Service with the Athabasca Chipewyan First Nation and Treasurer with Three Nations Energy. Jason recognizes that community well-being is very dynamic and extends well beyond traditional economic measurements. He has been involved since the conceptual stage of Three Nations Energy in the fall of 2017. It has been an exciting adventure from concept to construction and eventually energization, with a lot of learning along the way. Jason looks forward to the positive long-term community, environmental, and economic synergies that will be realized through Three Nations Energy. Welcome, Jason. Thank you for joining us today. And now I'm going to turn the mic over to Brian, who's going to begin our presentations, and we will switch the PowerPoint.
Thank you very much, Heather. There we are. Thank you very much, Heather, for the introduction, and thank you everybody for joining us here today. Every once in a while, I'll ask Matt, I think, if he can move the slides forward. And, you know, before we really dig into the exciting specifics around the Fort Chipewyan solar facility and get the perspective from Three Nations Energy and the technical team that was ultimately responsible for the execution of this work, it's my sincere pleasure to introduce the division of ATCO that I represent, and it was also the division that was responsible for the EPC of the portion of this facility that's owned by Three Nations Energy, and that's ATCO Infrastructure Services, or AIS. We're the EPC consulting and services arm of ATCO's energy expertise. So we manage not only electric generation, transmission, and distribution projects, but also on the natural gas side of our energy business, gas transmission, distribution, and related station projects worldwide. And this is exciting because it's done for third-party customers. The unique aspect that we bring to all of the services that we do is really the experience that only an owner and an operator can bring. For example, in the electric space, we've been designing, building, and then maintaining and operating those facilities for over 7 decades now. That kind of experience brings a lot of knowledge and a lot of learnings that we can then bring to our customers' projects as well. Our approach is to view it as a really collaborated, integrated design where the customer is an active participant and ATCO is involved when and where it makes the most sense for the project. Be that by offering planning and advice, consultation services, engineering, either as an owner's engineer or detailed design, procurement, construction, long-term operations and maintenance, or even training across that value chain. And training is something I'll highlight on quickly. Whenever we work within community, training is a key aspect of what we want to bring to municipalities, be they First Nations communities or anybody else in the service areas that we work in. Providing that training leads to long-term career opportunities and community growth. Our internal team of engineers, procurement professionals, constructors, and operations and maintenance experts are supplemented by an additional significant vendor database that we can draw on at any time to support any aspect of a project and ensure that that solution leads to schedule and cost efficiencies and customer solution success. Finally, I'd say that ATCO Infrastructure Services, while we're certainly able to participate in world-class turnkey EPC solutions like the Fort Chipewyan solar facility, We're also capable of only working in the unique service areas where it adds value to an overall project and it supports the overall project value chain. Next slide, please, Matt. Our approach to distributed energy resources or community generation is really no different than an approach to any other project. For example, with Fort Chipewyan Solar, we started with small initial consulting engagements. We call it a feasibility study, but really what it is an assessment of the viability of a project, location selection, and the economic analysis around it. Armed with this initial information, we, working strongly with the community, developed detailed plans, worked in partnership with the three communities to assess and find funding opportunities, and then ultimately moved into the EPC portion of this project as a team. The important part of this project was the teamwork that ATCO and Three Nations Energy worked together on. It was an iterative process. It ensured multiple touch points, feedback loops, and it ensured that the solution and that strong communication really was for the needs of the community as a whole. Projects can take this approach. They can certainly be the size of the Fort Chipewyan solar facility that we're speaking about today, but they can also be smaller, single locations in the community, such as schools or very important water treatment plants. The approach and the rigor that we put into the relationship and the partnership is always the same. And finally, although I know today we're speaking about solar and it's very exciting, the ultimate solution doesn't always necessarily need to be only solar or solar specific. Out of the gate, the concept is to avoid presupposing what a project could be or would be. We offer expertise as ATCO Infrastructure Services in combined heat and power or cogeneration facilities, wind, geothermal, ultimately whatever makes most sense for the unique needs of the customer and their demand profiles. Next slide, please, Matt. Indigenous partnerships is an absolute foundation to ATCO's approach to business, not only on this particular project and our relationship with Three Nations Energy, but across all of our businesses worldwide. The firm belief that ATCO holds is that a strong understanding of the interests of our Indigenous partners leads to long-term relationships, which strengthen the communities we work with and provide mutually beneficial results. With this in mind, we've developed 48 unique partnerships with Indigenous communities in Canada and across ATCO's various business lines. And on the next slide, we'll see the depth and the breadth of this relationships that we've built from the far north of Canada to the southern border with the United States, from the East Coast to the West Coast. You can see that we have representation in all of our provinces and all of the territories as well. And next slide, I think, Matt. And with that, it's a short intro, but it's now my pleasure to pass the presentation to Jason and Clayton. We're going to provide the perspective from Three Nations Energy on the drivers of the project and then the benefits that we've seen. Thank you.
All right, thanks, Brian. As Heather introduced me, my name is Clayton Stafford. I'm with Green Planet Energy Analytics, and I've had the privilege of working with the Three Nations behind Three Nations Energy for the last few years, and kind of been a bit of hired help to assist in bringing this together and in working with ATCO as we move forward with the project. I'll provide a little bit of background about the sort of the challenge and the solution drivers, and then I'll hand off to Jason Schultz from ACFN and to talk about sort of how the Three Nations Energy came about and how the Three Nations came together and got behind this project. So when we talk about Three Nations, the Three Nations we're speaking of are the Athabasca Chipewyan First Nation, the Mikisew Cree First Nation, and the Fort Chipewyan Métis Association. Next slide, Matt. And all of these Indigenous peoples have been living and working in the Peace Athabasca Delta in northeastern Alberta for generations. And the focal point where most of the folks live is the hamlet of Fort Chip in the regional municipality of Wood Buffalo. And it's, in the far northeastern corner of Alberta, not too far from the Northwest Territories border on the shore of Lake Athabasca. Next slide. So the remote location presents some challenges. I mean, it's fairly clear from the map that there probably aren't a lot of roads going up to that corner of the province. There aren't actually any year-round roads into the community of Fort Chip. So it's a fly-in community most of the year, or come in by boat, either up the Athabasca River from Fort McMurray or down the Slave River from the north. There is a winter road into the community that has ice bridges across several river crossings in the delta, and that sort of presents some challenges with getting materials into the community and sort of maintaining access in the community. Next slide. So just a little bit of background about how power was produced in Fort Chip prior to this project. Basically, before 2018, 100% of the electricity used in Fort Chip was generated by burning diesel fuel. ATCO operates the Third Lake generating station just outside the community to supply that power. That generating station has 4 diesel gen sets and about 3.3 million liters of diesel storage capacity. With that winter road providing only seasonal access into the community, it's necessary to store a full year's worth of diesel fuel for the plant and get all of that fuel into the community in the limited period when the winter road is open. Another important factor about power in Fort Chip for awareness and understanding is that it's an isolated electrical grid. It's not connected to the main grid in the province. And that local electrical grid is also operated by ATCO. Next slide. So I'll talk a little bit about the challenge that we were facing, or that the community was facing. In this chart, you can see basically a fairly steady growth in power consumption in the community of Fort Chip for the years 2012 to 2018 shown on this table. It's about an 18% increase in power consumption. And if you look at the bottom of the diesel usage column, I said on the last slide that we had 3.3 million liters of diesel storage, and you can see that there were 3.294 million liters consumed to produce power in 2018. So ATCO and the community were at the point where it was really, we were up against the point where we were running out of storage. We weren't running out of the ability to store enough diesel to get through a year. Next slide. So complicating factor in addition to that is just instability and unpredictability around the winter road into the community. We're all very aware of climate challenges in the world as a whole, and those are sometimes even greater in the north. So what we've seen is a winter road that is late to open and early to close. And for shipping diesel into the community, we need to get all of the ice crossings, all of the river crossings across the delta. We need to get several feet of ice thickness there before we can bring tanker trucks loaded with diesel fuel into the community. So the unpredictability, puts a question mark around whether just burning more diesel is gonna be a long-term solution or not. Next slide. So there people might say, well, what about bringing stuff in by barge? Is that a reasonable plan B? Barge shipping either up the Athabasca from Fort McMurray or down the Slave from the north is obviously dependent on river conditions. So it has its own variability and challenges, and having spent time trying to ship materials into the community by barge and organize all of that, it's challenging. It's not cheap. Barge schedules can be pretty unpredictable, and it comes with a significant environmental challenge if we start loading those barges up with diesel and bringing them up the river with sandbars and all the other stuff that you have to deal with there. So not a great option either. Next slide. So really, we were looking at a choice. The community and ATCO were together looking at a choice here. Either we add storage capacity, burn more diesel and hope the road holds out, or we look for another way. And the other way that was considered was building solar power generation capacity to reduce the diesel that we were burning, and at least buy some time. We've also been working in the community and with all of the nations on the efficiency side of the equation to try to bend the curve down, I guess, on the growth in consumption as well. So that's the choice that the community was facing. Next slide. And that really led to the sort of the impetus behind the formation of Three Nations Energy, and to speak about sort of how the community came together and partnered with ATCO in making this happen. I'll introduce Jason Schultz, Executive Director of Strategic Advisory Services with ACFN, and also actually President of 3NE. We rotate the executive positions through each of the nations, and this year Jason gets to be president. Jason.
Good afternoon, everybody. Nice to see you. Next slide, please. So when I first joined ACFN in October of 2017, one of the first things I was tasked with was looking at a solar plant in Fort Chip. ATCO had approached the Athabasca Chipewyan First Nation to assess overall interest and start the dialogue from bringing it from a conceptual stage to eventually shovels in the ground. Being new to the role, it sounded like an exciting opportunity, but I'd never had the experience of building a solar plant or being involved with a solar plant. So we envisioned a two-phase rollout for the project. Phase one was 600 kilowatts, and it was 100% owned by ATCO, and phase two was originally envisioned at 2.2 kilowatts, and we're currently adding another 1.5 megawatts to that for the 2.35 megawatts in total. But we worked with ATCO to move this forward and get community buy-in. Initially, we approached NRCan under the Clean Energy for Rural and Remote Communities as a viable funding path. After a lot of dialogue and back and forth, once we finally did submit our application, we received a successful outcome that we had been chosen to move forward. And the Alberta government had also approached us in parallel based on the successful outcome for the CERC Round 2 funding. So with that, there was a bit of a caveat dangled. We were ecstatic that we were chosen for funding. At the same time, we were asked to share the opportunity and the funding with Mikisew Cree First Nation and Fort Chipewyan Métis Local. So there was a bunch of community engagement along the way and buy-in to get equal ownership among the three groups and bring the community up to speed on this initiative and what it might do to improve quality of life, air quality, mitigate environmental mitigate environmental harm to the community. Being a remote community, Fort Chipewyan has been heavily impacted over the years by climate change and global warming per se. So we were fairly successful in getting the buy-in. We were able to get the three stakeholder groups on board, and we moved forward to start construction. We started shipping the solar panels up the winter road, and we commenced construction in spring of 2020, and the project was eventually energized in January of 2021. So it's been an exciting project that provides opportunities for employment locally, it provides opportunities for learning locally, and it provides an ongoing revenue stream and educational opportunities in the community. This is also made possible through the 1.6 megawatt battery and control unit, which is also owned by ATCO and integrates the solar and diesel into the community, where although we're early in our operational stage, we're optimistic that the solar combined with diesel generation will reduce diesel consumption in the community by 800,000 liters of diesel annually, thereby making better, more efficient use of the existing infrastructure and improving air quality locally. Next slide, please. Having said that, I'm happy to turn the presentation over to Matthew Wright. Thank you.
Thank you, Jason. So as Jason mentioned, the project that I'm about to talk to about was the first phase of ATCO's phase 1 solar. And we started back in 2017, 2018, looking at the land available to put phase 1 600 kilowatt solar PV system here. And we wanted to go and look at a chunk of land that was a little bit larger to accommodate different challenges that we might encounter, such as civil, geotech, laydown areas that would be a little bit more challenging to deal with in a remote area than somewhere closer to like an urban area like Edmonton or Calgary. So we had to plan for a little bit more land than we would normally in other areas. So this is the area prior to construction of phase 1 and phase 2. As mentioned before, the logistical challenges of this project are quite immense. Building a solar farm is challenging, and then adding the logistics of shipping all the material, which has a short window of time, is even more challenging. So generally, the road is open from December to around March for passenger vehicles. However, there's a period of time, about 4 to 6 weeks, where the winter road is rated for heavy haul of around 40,000 kilograms, where we can ship up large amounts of equipment on beeline trucks. So we were able to take what we already do with our diesel fuel shipment and also incorporate our shipping for our project material and send it up the road during the winter. It became more and more challenging throughout 2018, 2019, and 2020 to get all of the material up. The window of the road continued to shrink throughout the last couple of years. And I'd say 2020, 2021 was our most challenging year to get the additional material up for the additional phase of solar that Jason was mentioning there. One of the unique things that we tried to incorporate in this project was how do we minimize some of the construction and incorporate a little bit more of a modular build. So this is a little bit of a picture of our design and our system that we pre-commissioned at NISCU, where we took our inverters for the solar PV system and put them in a container and put them up the road. So we were able to test them. We were able to make sure they're updated, working, testing them in the sense of we were able to put solar PV in and output them to the grid at our NISCU facility that you're seeing here as well. We wanted to go this route too because the local temperatures get greater than -40. So installation outdoors wasn't necessarily going to work for this application. Here's a couple of pictures of the phase 1 solar project, again, constructed back in 2018, 2019 on this was the southwest part of the piece of land that we'll see in a little bit of a future picture. We partnered with some of the folks locally to help construct the solar farm. We've got some issues with timing on this slide here. We partnered with some folks locally to help us construct the facility. We also had some of our local members of ATCO come out and do the wiring of the electrical for our high voltage and connect the solar farm and get it operational. With that, from phase 1, we kind of started into the second phase when we introduced the 3&E solar farm into the mix, which I'll pass off to Hassam to talk about what the microgrid of Fort Chip looks like.
Thank you, Matt. Good afternoon, everyone. This slide shows the overview of Fort Chipewyan microgrid system. So in phase 1, we basically pushed the grid to its limits by introducing as much solar as it could host without adding any new components. As a result, in order to enable phase 2, we needed to add some other components like battery energy storage or BESS, and also microgrid controllers. As you can see, this microgrid consists of solar PV, BESS, existing diesel generators, and microgrid controllers which serve the community. Next slide, please, Matt. So phase two construction started in 2019 and ended in 2020. Phase two included the engineering, procurement, and installation of 2.3 megawatt DC and 1.875 megawatt AC solar, and 16 string inverters in 2 different buildings, and also over 5,700 PV modules. It's a fixed tilt system, 35-degree facing south. Next one, please. Construction challenges. Where should I start? Obviously, the extreme temperatures up in the north and short construction season is one of the biggest challenges. The second challenge is limited or no access to heavy equipment at site. And also, there is no local suppliers or distributors of electrical equipments or solar-related equipment. So we cannot afford forgetting something. The other problem is limited hosting hospitality capacity in the community, especially during the pandemic and when we have 2 concurrent projects going at the same time, the battery project and the solar project. So multiple teams on site at the same time, which makes it even more challenging. Next one, please. So how is it different to add solar to an isolated electrical system comparing to adding solar in Edmonton or Calgary, for example? First one, when you add solar to a small off-grid system, the solar PV generation intermittency can create large swings in voltage and frequency, which can jeopardize the power quality and reliability of the system. These swings can cause lighting flickers, they can cause overheating or malfunctioning of the electric machines. It can damage the sensitive equipment or even can cause blackouts. As a result, you need a fast response battery energy storage system to flatten the generation profile of the PV. And now that you have multiple sources such as BESS, PV, and the existing gensets, you need a microgrid controller to act as the eye and brain of the system and control and orchestrate all different resources. The other difference is commissioning of the solar inverters is not plug and play like when you do it in Edmonton or Calgary. First off, you need to integrate them with microgrid controllers. You have to establish communication between them. The inverters need to send signals to the MGC and receive the dispatch signals from them. The other component is the inverters should contribute in VAR support. Otherwise, if they continue working at unity power factor, the KVARs need to be supplied from the power plant, and it results in poor power factor in the gensets, and that's not an optimal operation for them. The other challenge is you cannot rely on the factory default settings for over voltage, under voltage, or frequency or under frequency settings. And you need to coordinate and change these settings in your inverters so that they match with whatever you have in the microgrid. You cannot afford tripping them too soon or too late. Next slide, please. This picture shows the aerial view of the generation facilities in Fort Chipewyan as of January 2021. As you can see on the far left side, phase 1 solar owned by ATCO, and then phase 2 solar owned by Three Nations Energy. And then in the middle, you have the BESS. This is very amazing how small this component is comparing to the rest of the components, but it's actually what that enables the additional solar. And then obviously the diesel generator rooms and the massive diesel storage tanks on the far right side. You can compare the whole facility with the airstrip in the background. Next one, please. And finally, the BESS system. So it's located in the Third Lake Power Plant yard. As you can see in the left picture, there are two buildings. The taller building is the battery building. So it's full of batteries. And then the smaller building is the inverter building. It's full of modular inverters. Inside the battery building, you can see on the right picture, there are 22 racks and 256 battery modules. Like the shoe boxes with the PC fans on them, we call them battery modules. And inside each module, there are 22 cells. And these are pouch cells, not cylindric cells in this case. So over 5,800 battery cells in this building, plus fire suppression system, HVAC, BMS or battery management system, which is the brain of the battery, and some other electrical accessories. It's a 1.675 megawatt hour, 1.7 megawatt battery. Next slide, please. Thank you so much for your attention, and it's time for your questions.
Wonderful. Thank you so much. You sure are tight presenters. I'm impressed. I didn't know if 5 of you could keep that presentation so succinct, but I appreciate it. Matt, if you want to turn off your screen share now, we can have all the panelists up for the Q&A. I think that would work well. So for those of you who haven't already, please enter some questions in the Q&A box. I see we have a number of questions going there. And so we're gonna pose those to our panelists. You can also just a reminder to upvote your questions. If you'd rather not ask and you just want to amplify someone else's question, you can always vote for their question to pop up to the top of the screen. So again, thank you to our presenters. Let's kick things off here with our first question from Melody. She's curious if the Fort Chipewyan solar arrays are going to be stable enough to sustain the community needs throughout the winter when solar rays are weaker. Will the isolated generation be available if the solar is not meeting the needs? Who would like to take a stab at that one? We're talking reliability here. Yes, Matt, please.
Thanks for the question. Yes, the answer is yes, there will be sufficient amount of power quality and reliability up in the community when the solar is not as strong. The solar PV will operate, but most likely the prime power will be served from the battery and the diesel generation of the community. So we're going to be essentially shifting the mix of the energy from the time of the year. So in the winter time, primarily it'd be diesel with battery, then solar. And then as we drift from spring to summer and fall, we start to use more of the solar and shut the diesels off.
Yeah, and I think that leads to a question I had actually as a follow-up, which is there a vision to get to 100% renewables on the grid? Will the three nations ever get to a point where they have enough solar and battery potential or other renewables mixed in that they can actually get off the diesel completely?
So the challenge with that one is because we have very short and dark days in winter, we need a very long duration of storage and like an oversized PV system so that we can support the community during the winter if we want to shift to 100% renewable. With the existing technology, I found it very challenging unless we find a very cost-effective, long duration of storage.
Mm-hmm. It is nice to see the price of storage is starting to come down some more. So maybe that will be a possibility in the future. But I'll get to more of our audience questions now. Thank you for fielding one of my own. I appreciate it. Doug is wondering if you can comment more on the educational aspects of the project. I think Clayton and Jason, you may have mentioned that there were some educational aspects as well. I think people are curious to hear more about that piece.
Sure, I can speak to that, and Jason can pick up the pieces I miss. But yeah, we've had a fairly significant community education and engagement component to the project. there's a lot of interest in the community. And so as part of the project, we've created and made available a number of educational resources through the Three Nations Energy website. Because of the pandemic, direct face-to-face engagement has been a little more challenging, but we still have had a lot of conversations and have shared a lot of materials. One interesting thing that we've been doing, all Three Nations in the community have been just to kind of both address another challenge and to make this more real at a personal level. We've been deploying off-grid solar PV systems at remote cabins out on the traditional lands of these First Nations. So to date, we've got about 13 systems deployed on cabins, and we've got another phase of that program going this year. But that's basically giving, four solar panels, 4 batteries, charge controller, and inverter, and it's allowing people to be out at their cabins year round and turn off the generators. So that, to me, that one has really made a connection to the big solar project for the people in the community.
Yeah, I think I actually saw a video about those cabins, and they were really amazing. And I think one of the things a lot of folks from Edmonton and Calgary might not realize is a lot of those cabins are actually being utilized for people's livelihoods as well. It's not just like a vacation destination, right? It's actually, people are actually doing some serious hunting and other things that they actually need to be out there for. So it's neat to see the work that you folks are doing in the community at large. Jason, anything to add on the educational aspect?
Yeah, I can just add a little bit to what Clayton stated already. So going forward for the life of the project, 15% of the revenue will be invested in community education opportunities. So a lot of that is yet to be determined. But if you go to our website or our Facebook page, we're continually adding information. We're also partnering with the local schools to provide additional information. And then we've expanded, I guess, beyond the solar to do some things around firewood processing. We've introduced biking to the community, etc. So just very environmentally friendly choices, as well as some stuff around food sustainability and whatnot. So it's a more holistic approach than just solar, but it complements environmental friendly technology and some of the traditional practices as well.
Wonderful. And I think you're already starting to touch on the next question I see here. So I'll pass the baton back to you. But what emphasis has been placed on efficiency measures to bend the curve of energy consumption? I think you started touching on that, and I heard a bit about that in the presentation earlier, but I guess these things go hand in hand. So maybe you could mention a little bit more about the energy efficiency pieces.
Yeah, well, we're doing a lot of things around energy efficiency in the community, including some energy efficiency audits in the current housing stock and retrofitting things with more modern furnaces, better windows, simple things such as door sweeps, etc. HRVs in some of the buildings. We're also looking at using wood heat to further reduce some of the heating bills in the community, etc. We're looking at other technology to further improve opportunities in the community, further reductions of diesel consumption by growing local produce in the community. We have a grocery unit there, and we're looking to further expand on the gardening initiative and food production in the community. And Clayton may wish to further elaborate on that, but those are some of the examples that come to mind, and I'm sure there's a lot more to come in the years ahead.
Yeah, just one. I think what I've seen over the last few years, in 2018, both ACFN and MCFN took the step of developing a community energy plan, which was looking at, using cleaner energy and using energy more efficiently. And out of that work, there are probably 25 or 30 projects initiated or planned in the community to address aspects of energy efficiency. So it's becoming sort of top of mind in the planning that the communities are doing, and certainly sort of front and center as new construction proceeds and as their maintenance and renovation of existing buildings continues.
Yeah, thank you for that. Yeah, I know housing has often been an issue in remote communities as well. And so I think that the construction of good quality, energy efficient homes can obviously have many of the same challenges you're discussing for even just getting the equipment up and the workers there and everything to do that. So I appreciate these are all very challenging initiatives to work on. I have a question here from Alan. He's wondering, were any other generation options such as wind, hydro, and I saw someone else talking about geothermal when it comes to heating. Were any of these other options considered? Excess green power generation could then be sent south to the oil sands facilities. So I guess there's a double barrel question there. One is about the wind and hydro and other considerations, and the other is there any potential for you guys to ship some of your energy out of that area if or is your grid like completely separate from the oil sands facilities?
I'll take a stab at that one there, Heather. I'll answer the last question first. There is no way to transport excess energy. We are completely isolated from the rest of the interconnected system. But the first question, there was several other technologies explored. It doesn't mean that they aren't still viable, but I think what we looked at was the timing it takes to do a project, coupled with the terrain considerations and the grant timelines. So it really kind of lended itself to a good fit of risk and schedule and cost and the funding available at the time. We looked at wind. I think there's some challenges there around just any sizable amount of wind would be challenging to install. There's a lot of challenges up there with respect to the geotech. Like the pictures we saw on the screen there was a lot of sand. The solar farm area was 8 meters of sand across the whole land. However, you go 100 meters east or south, it's Canadian Shield. So you're really challenged by what land you have to work with and the civil constraints that are there. So there's potential to look at different technologies as they we look at this overall energy mix, I think. But solar was really, I think, the most logical fit given the timing and the costs and the schedule.
Yeah, I appreciate that.
Maybe add just a little bit to that. And we did do an assessment of the wind. There's a couple of different Environment Canada monitoring stations, one at the airport and one just out on an island in the lake near the community. And really, we don't. It's not very. The average wind speed isn't very favorable to wind production. It's when you look at what you get, with current turbines available, you're probably looking at operating below 10% efficiency on those turbines most of the time. Now it might get a little better if you can get up high enough, but then you're up against some of the challenges. I mean, installing turbines, the height of the installation tends to be limited by the size of the crane that you can get into the community or into the on site to install. So it's a bit of a challenge. Just comment on hydro. That's a bit of a sensitive topic in the community generally. The Fort Chip and the Peace Athabasca Delta has been significantly impacted by upstream hydro on the Peace River in BC, and will be further impacted as Site C comes online. So, while there is lots of stream flow and potential there, it is a challenge to consider any large scale hydro development on top of what's already going on.
Yeah, there are certainly many ecological factors beyond just the GHG emissions you have to look at with each of these renewable technologies. So, and it's interesting to hear, just talking about the differences between northern Alberta in terms of wind and southern Alberta, because obviously a lot of folks are going with wind in the south, and anyone who's been to Lethbridge knows why. You can't even keep a hat on your head there. So I guess I'd be curious to know, I understand that 3NE recently made some decisions to invest in some utility scale projects in southern Alberta. And I know that's not what you were presenting on today, but I'm wondering if you folks could comment on that, because that hit the news recently, and our members were very interested to see that type of local investment happening in utility scale solar. I believe it was solar, maybe wind. You could correct me if I'm wrong.
I'll take that question for now. It was actually the Athabasca Chipewyan First Nation that made the investment, not Three Nations Energy. So this was our first foray through Three Nations Energy, and I guess it was a catalyst of such. But I think, we're focusing on the Three Nations Energy project per se. They are solar projects in partnership with Concord Pacific or Concord Green Energy, which is a subsidiary. But we'd be happy to discuss that maybe at a future engagement as such.
Yeah, absolutely. I think definitely there's an interest in learning more about that. So thanks for clarifying. So we have a question here from Alan. He's wondering, what are the panel ratings? 400 watts per panel, question mark. Also, you mentioned that panels at 35-degree slope and fixed is what you went with. Were there any considerations to use of bifacials to capture solar reflection on the backside of the arrays? I know that's where they went in Innisfail. We heard about that recently. So you made a slightly different decision, and maybe you could talk us through that.
Sure. Bifacial was definitely an option for us, and the capacity addition that Jason mentioned in the beginning of the presentation, the new row the Three Nation Energy is adding currently is a bifacial module. And even in phase one of the rows that ATCO added was bifacial. At that time, we were investigating that technology, and we are, after more than a year or 2 years now, our understanding is actually bifacial panels are very suitable and favorable in northern climates because of the gain they get from the back of the panel. And also that gain helps warm up the module in winter and melting the snow faster. So yes, after our investigations in the first 2 phases, we realized that that's a very good option for Alberta climate. And what was the first part of the question again?
I think it was about the angle, and the question's gone now from my screen, but I'm pretty sure they're curious about the angle you chose, if I'm not mistaken. Here,
Okay.
let me see if I could pull that up. The first part of it. Oh, I got it back here. What are the panel ratings? That was the first part of the question.
Okay. For phase one, there was a mix of 400 watt panels for monofacials and 385 watt panels for bifacial. For phase two, the monofacials are 395, and bifacial row, which is being installed right now, is 405 watt modules.
Right, and I think this leads to our next question, which is similar, is around why not a steeper slope? I guess our assumption is the further north you go, the more slope you need on those, but you chose 35 degrees, so.
Yes, in theory, like the higher slopes will result in more yield, but in practice, that's going to be a customized solution. And if we wanted to go with that route, basically, we had to deal with a customized solution. That's not something you want to experience in a remote area like Fort Chip. So you have to rely on a system that you can find the spare parts. You can find engineering support, and it's off the shelf. That's the reason we didn't go further than 35 degrees.
The other piece there too, I'll add to that as well, and then you can go, Clayton.
I was just gonna say we did simulations of a number of different configurations, and one of the things you get up against when you're in the north is do you optimize for winter production, or do you maximize what you get from the long days the rest of the year? And I think that's where, if you go to a steeper angle, you do get somewhat better winter production, but so if you look at the percentage of what you produce over the course of the year, so little of that is in winter versus summer that, we were better off in terms of total usable production to kind of optimize for when the sun is when we have those long days and we want to capture the the sun as it moves from the northeast and down and across and back up to the northwest. So that was a factor.
Anything to add there, Matt, as well?
Actually, I have one more thing to add. When you
Sure.
when you increase the tilts, then you have to increase the row to row spacing to make sure you don't increase the shading losses. But when you have a limited land, like you can't go beyond a row to row spacing. So increasing the tilt does not always mean increasing the yield.
Well, that's super interesting. And I think also what I heard in your response, Clayton, it makes me think about how your system, because you have the battery storage integrated, would be quite different than a lot of the other systems that we have been learning about on our Thursday webinars. You can maximize your summer because you're going to store it. Whereas other people, they have to think more about the full 12 months than you do, because most the other installations to date haven't had a lot of storage. But we're going to see big shifts as storage is being integrated more and more. So there'll probably be more and more systems designed a little bit more like yours to optimize the summer sun. So that's helpful for us to think through as this solar sector changes. Thank you. Here we have a question about, do you have any estimates on how much incentive or support we will need to increase the share of solar electric power to a proper level in the province? So that's a bit of a broad question. I don't know who would take a stab at that, but what's it going to take for us to really get to this, I guess, 30% renewable on the grid that we have a dream of getting to? Do we need more government support and incentive to get there?
I guess I can throw something out there. I think the need for an incentive is reducing over time. We're not going to talk a lot about the projects that ACFN has recently invested in, but they're merchant power solar projects in southern Alberta with no advanced PPA in place, and the economics works without incentive. So I think for the province as a whole, it's solar can compete without a significant incentive. When you get up into Fort Chip, it's a little more challenging because the cost of doing a project up there is more challenging. We're actually working with Three Nations Energy to move forward with some to seek a bit of a change to the small scale generation regulation that will, right now it kind of disadvantages isolated communities and doesn't recognize the added cost of producing there. But so anyways, that's my thoughts on that one.
Oh, it's really helpful to understand. I think we have, I was listening to a presentation the other day about, well, Edmonton has rebates, Calgary doesn't. But someone was saying, well, given that we can't produce quite as much solar energy in Edmonton, in many ways, the rebate actually offsets the overall cost, and the payback on your system at a household level in the northern community, which is not nearly as far north as you are, ends up being about similar because of the rebate. And so it's interesting as we go forward as a country, we might really need to see rebates being very focused in northern communities, further north than Edmonton even, because of those factors that you mentioned. So I appreciate that perspective from the north. I think a lot of us, when we hear about Fort Chip in the news, we imagine it's like right close to Fort McMurray, right? Because you're in the same regional municipality of Wood Buffalo. But then when I looked on the map in your beginning of your presentation, I thought, oh my gosh, it's further from Fort McMurray than Calgary is from Edmonton. Like that's amazing. They're actually not at all near each other. So I'm really glad you showed that map. It helps us understand exactly how far north this community is, exactly how unique it is, and also, of course, the fact that you're really isolated there. So thank you for helping us understand that better. We've touched on this question already before, But I'm wondering if anyone has anything to add about snow, because people are always wondering about snow and how does the snow impact the panels in the winter. This is I even have some friends who like to actually shovel snow off their their panels. It's not recommended, but there are people who are very worried about snow. So I'm wondering if you have anything further you want to add on that piece, or do you feel you've already covered the snow piece enough?
So obviously the snow impacts the production, but there are ways to reduce or eliminate that impact. Obviously, removing that snow with a snow blower or other techniques is an option, but there has to be some cost benefit analysis to see if it makes sense to actually pay somebody to go and remove the snow from a such a large facility, especially during the short winter days. There is not much production anyways, so it has to be carefully studied. The other thing is using bifacial modules, but the majority of production we see in this system is from March to October anyways.
Okay, thank you for that. Yeah, it is actually neat to see all the solar installations going in Nunavut as well as Yukon. And so I know that they also have snow, and yet we're seeing some excellent generation capacity in those communities as well. So I think we're slowly overcoming the notion that snow will slow us down with solar. So it's nice to hear your perspective.
Just add a bit to that, because we finished construction last summer. We went through a full winter this year. With the solar farm in place, and what I saw over the course of the winter was basically, yes, we had a fair bit of snow up in Fort Chip this year. It didn't accumulate. The panels self cleared just from a combination of wind and heating and the snow sliding off of them. So really, even in a year where we had, several feet of snow up in Fort Chip, generally there was no snow on the panels when you drove by, unless it had snowed recently.
Interesting. That's good to know. Thank you. Doug is wondering, did you do a carbon accounting analysis? What are the greenhouse gas savings from this project? And if you did a carbon accounting, did you account for the land use change from removing trees from the site? So curiosity about the GHGs and the trees and all that jazz. Anyone want to touch on that?
We did do carbon calculations based on the offset of the diesel, but I don't know if anybody internally did the calculations associated to the land. Like the existing trees there were actually in pretty rough shape, so there was quite a few spotty areas in some areas. And then I think Clayton and 3NE took a lot of the other trees that were salvageable and have turned them into timber for a separate initiative. So I don't think we have a specific number for the holistic picture that was asked there, but maybe talk Clayton about the logging piece there.
Yeah, well, yes, we given 2 minutes, I can find the actual number of the annual GHG reductions associated with it. So it didn't explicitly factor in the loss of the trees from clearing 6 hectares of land for the solar farm. What it did consider was both the burner tip emissions of the diesel fuel in Fort Chip, plus the emissions associated with getting the diesel fuel up to Fort Chip. That analysis was done, and I'll look in another file and I'll have that number for you before we close things out here.
Oh, that's kind of you, just doing some digging on the fly. So thank you for that. No, it's good to get a sense of what factors were considered. So thank you. Mark is wondering, what were the challenges with the foundations? So we all did notice the sand, and thank you for showing us the sand, because that was shocking. Can you describe the foundations, and did you have foundation options in case of installation problems?
We probably did a little bit more geotech than you traditionally would do for a solar farm of this size. We wanted to get a very good sense of what what we were up against for foundations. And out of all the boreholes we did, I think only one was different than the others, and all of the other boreholes were, again, 8 to 9 meters of sand. The top layer was the most challenging bit, but for foundations, they were a helical screw pile foundation. So we were fortunate that there was no bedrock below or Canadian shield to deal with, but the challenge becomes is the freeze and thaw cycles of the area and the cold temperatures, and when you can get up there and start constructing based on the ice road, make it kind of that challenging piece there. So we had to, I think we had to do some pre-drilling of the foundations to get through the first couple feet, make some changes to the foundations as they did some of the installation. I think in the first little bit, they were running into some challenges with torque, but were resolved after the first couple rows there. So.
Okay.
Yeah,
great.
I think in the phase 2 where we had about 600 screw piles installed, I think we only had 5 refusals where we couldn't get to full depth on the screw piles. So not bad overall. The
Great.
bigger challenge is getting a big enough torque head up to Fort Chip to be able to screw them into the ground, and then dealing with repairs when something breaks.
Yeah, getting the repair folks up. I mean, we've heard about that too. And even just when we have this conversation about how do remote communities have access to good quality water, and often the issue is they might have a facility set up, but there's nothing in place to maintain the facility in perpetuity. And so it sounds like there could be some similar challenges here, but you've got a long-term partnership here with ATCO, so hopefully that helps overcome some of those. I guess maybe do you want to touch on that maintenance piece while we're on the topic and what your strategies are? Because we do hear about this all the time. The installation went great and there's nobody maintaining it. So how are you folks overcoming that in the long term?
Well, I can respond there too, but I should maybe wait longer and let other people talk. But yeah, as we're fortunate to have been able to engage ATCO Electric to basically provide operations and maintenance services in conjunction with their Third Lake plant, and we've contracted that for 3 years at this point. So that gives Three Nations Energy some time to decide how much of the O&M work they want to take on themselves. It certainly creates some efficiencies from an operations perspective in that we have staff and alarm monitoring and everything else in place at the plant that we're just extending to cover the solar facility as well. So we're fortunate in that regard here.
Great. And it's nice to hear, that there is that opportunity to think about that in-house capacity and how much, in which areas you want to build it and whatnot. So that's great. Sometimes you hear about partnerships where you're locked in for 50 years or something, and there's really no opportunity to grow that relationship and change it in any way. So that's neat to hear the timelines you're working on. Brian, did you have something to add there?
Yeah, I was going to add to it, and kind of like I alluded to in the early part of the presentation, training and skill development is pretty key to what ATCO's ethos is in the communities, and that 3-year operations agreement needs to, in my mind, and does include training and shadowing and learning throughout that process as well. So the intention is a long-term partnership with transition in the right areas.
Neat. Thanks for expanding on that. So Gino's wondering, how long does your storage last? So, once you've got those batteries fully charged and we're heading into the winter months, does it get you as far as, December or January? When do you have to flip the switch and go off battery onto diesel? Typically, I guess it's the first year of operations. So, yeah, Hassam?
So the battery is 1.67 megawatt hours, and that's a 1-hour battery. But basically, as I mentioned in my presentation, the main purpose of that battery is to flatten the PV generation. It's not a long-term or long-duration battery to basically capture the solar during the day and then release during the night and supply the whole community overnight. That's not the main purpose. It's to basically flatten the generation and basically adding the hosting capacity to the system so that we can add more and more solar without jeopardizing the stability of the grid. That's the purpose of the battery. So yes, it can hold 1.7 megawatts of load for 1 hour if it's fully charged, but that's not the best way to use that battery.
And there's a question here now about long-term plan and vision. So I wonder if Jason, if you'd like to touch on some of the visionary pieces for the future. And people are very future-oriented these days, so it'd be interesting to hear.
Well, I think in terms of Three Nations Energy, it's a catalyst for change in the community. It's presented some opportunities to local youth, maybe present some opportunities for future education, typically being in the heart of the oil sands. When it came to employment opportunities, people were more drawn towards the opportunities in Fort McMurray and more traditional opportunities. But I think this opens up, a lot more broad-based vision for opportunities that largely have yet to be determined moving forward. I think the community as a whole, as well as the various nations in the community, will continue to embrace renewable energy, whether it be locally or outside of our backyard, as we see with the ACFN initiatives in the South. And I think further to that, there's a lot to be determined, although there's many initiatives identified in the community energy plans that Clayton mentioned earlier. As technology develops, as alternatives are presented, as costs are further driven down through economies of scale and synergies in manufacturing, I think it'll be an exciting opportunity, but there's a lot yet to come. So in terms of short to medium term, I think we'll use the community energy plans to potentially guide us. There'll probably be a few detours along the way with other side projects that maybe haven't been recognized, but longer term, I'm curious as to where it might go myself.
Yeah, seems to have a lot of momentum. I know when we first shared an article about this initiative on just our Facebook page, it's lit up. And I mean, I have never seen anything light up like that on our feed before. So then I said, Echo, you guys, can you put together a webinar with us on this? So I really appreciate you all participating, because there was just this electricity generated through even just the announcement of this project throughout the province. So it's really inspiring to everybody. I think we have time for one last question, and I think it's a very good one, which is around land and land ownership. And your project is likely very unique in terms of land ownership compared to elsewhere in the province. So could you talk us through, is the project located on First Nations land? How does that impact the project? Some of those not land use, I guess the question is around ownership. Who wants to touch on that piece for us?
Okay, I was waiting, but so while this the land where we've developed for the solar farm is certainly within the traditional territory of these First Nations, it's not on reserve land. So we're basically developing on Crown land and have secured a long-term lease from the Crown for the land. So it's not all that different from elsewhere in the province where you might be looking at developing a project on Crown land.
That's great to know. Yeah, I think a lot of us weren't aware of that. So thanks for sharing. And I had heard you can't do wind and solar on Crown land, but it sounds like you were able to get permission. So maybe just touch on that piece for us, because there are plenty of folks out there telling me you can't and we want to, and you guys have done it. So maybe you could help me understand, is that permit that you received something others can apply for as well to get a one-off or something like that?
We were the first to apply and go through that process. I believe there might be a directive within the government. I don't know, can't speak on what others could do, but we had to go through a period of time and work with the government to solidify that permit and lease, because it was the first and it was kind of trudging new paths, right? So
Yeah, that's good to
So
know.
And some of the folks weren't the ones doing the permitting work. We have a different group who support that, but it was a first for many.
I also think it's important to consider the specifics of each site. I mean, there's Crown land and there's Crown land. This particular piece of land is between an existing power plant and an airport. So we were, in terms of the pre-existing disruption of the natural environment, our incremental impact was quite small. I mean, we still had to go through the obtaining the required environmental approvals and doing the wildlife surveys in advance and all of that kind of stuff. But the fact that we were in a site with significant industrial activity already made a difference.
Okay. This is really, really helpful for us to understand. So thank you all for sharing your insights on this this project. I think we have to wrap it up there. There are many questions. We could keep grilling you folks all day, but I want to respect everyone's time and the commitment they've made. So I'll just wrap up here on schedule by thanking you five very much again for taking time to share with us today. And want to thank all our attendees. We had a great attendance today, which is lovely to see, and many who stuck with us to the bitter end, even beyond their lunch hour. So that's a really wonderful testament to the information you're providing. And I want to encourage everyone to stay tuned, follow us on social media, and sign up for our newsletter. You can get that at the bottom of solaralberta.ca. And of course, if you become a member of Solar Alberta, like ATCO is, you could get our member bulletins and a variety of other member benefits as well. So it certainly encouraged membership within our organization. I would like to have everybody in the mix. So thanks again, everyone. Have a wonderful day, and look forward to seeing you all again soon.
Thank you.
Thank you.
Thank you.
Thanks, folks.
Thank you.